Here we have a piece of paper, plastic pipe, and some rabbit's fur. If we charge the plastic pipe and bring it by the uncharged or neutral piece of paper, there's an interaction. Why does a neutral object interact with a charged object? Let's figure this out. Let's explore this example of the piece of paper and the charged plastic pipe. The paper is drawn, represented by 6 charge pairs. There's an equal number of positive charges and negative charges in this object, and so this piece of paper is neutral. The plastic pipe has been rubbed with fur, and it has gained a net negative charge. We see that represented by the extra electrons on the pipe. As we bring the pipe closer to the paper, the extra electrons in the pipe interact with the charges in the paper, with both the electrons and the positively charged particles. The electrons are able to move slightly, and so they get pushed away or repelled by the extra electrons in the pipe, which looks something like this. Because paper is an insulator, it has an especially tight hold on its electrons, and we show that by drawing an oval around the positive and negative charges that we see in our charge diagram. This reminds us that this electron is still very tightly bound to this positively charged particle. When this happens, one side of the piece of paper ends up positively charged. The other side of the piece of paper ends up negatively charged. And now the paper as a whole is able to interact with the charged pipe. Since this part of the paper is positively charged, the paper gets attracted to the negative charges in the pipe, and the paper as a whole moves towards the pipe. And this is why a neutral object is attracted to a charged one. This object here still has the same number of positive charges, 6, and negative charges, 6, and so its net charge is still neutral. If we move the pipe to a different location, the electrons inside would shift around in response, kind of like this. Notice how we're showing that the electrons are no longer overlapping with the positively charged particles. This is our way of showing the idea of polarization. And now, it's the bottom part of the paper that is positively charged, the upper part negatively charged, but as a whole, the paper still has the same 6 units of positive charge and 6 units of negative charge, so it remains neutral. But it interacts electrically because the charges have been shifted inside it. And this is the key idea behind polarization.